Okay. Hello, everyone. Welcome to FAccTRec 2021 workshop on responsible recommendation. We are very happy to see you here. This workshop is organized by Michael Ekstrand, Nassim Sombari, Pierre-Nicolas Schiave, and me, Toshihiro Kamishima. So many thanks to reviewers. We can't hold this workshop without their efforts. This workshop series started at RecSys 2017. Following the last year, this year's workshop is held in a fully virtual format. For the future FAccTRec 5, we'd like to discuss the direction of this workshop in the panel session. These are topics of this workshop. What does it mean for a recommender to be socially responsible, and how to carry out it? It would have a relation with fairness, accountability, transparency, compliance, and safety. This workshop collects position papers in a social viewpoint and research papers in a technical viewpoint. 14 papers were submitted and 11 papers were accepted in this year. The workshop composed of 4 sessions, 1 for panel discussion and 3 for contributed presentations. For questions and feedbacks, please use Zoom chat. We welcome your feedbacks. Please remind, permitted presentations will be recorded, but Q&A, the panel will not record it. The workshop starts by the panel discussion, past and next step for FAccTRec. Let's welcome, Robin is here. Okay. Let's welcome Robin, Luca. Luca, okay. Luca, Zia, and Michael. Please start.
Our work estimating and penalizing preference shifts in recommender systems. So let me just see. Okay, yeah. So assume you're given 3 different recommender system policies and you need to decide which one to deploy to real users. Say that you choose policy 3 here, which was trained with RL, as it is performing best according to your engagement metrics. So let's assume for a moment that we could visualize how the preferences of a user would evolve over time when interacting with such a recommender system. So here we see the preferences of the user drift towards a certain area of the preference space. And this preference continuum on the y-axis could be grounded in various ways. For this specific grounding, we could say that the user over time starts preferring sensationalized news to dry journalism. So here we see a preference trajectory for an individual user, but we could also consider how the preferences of an entire cohort of initially similar users evolve when interacting with this policy. So in this case, we would see that most of the people in this cohort end up preferring sensationalized news after some amount of interaction with the system. Okay, so let's now assume that we could see for the same cohort of users what the preference shifts would be when interacting with various different types of policies. One thing to note here is that under different policies, the induced preferences look quite different. So in this case, so it basically seems that as a system designer, when one is choosing a policy to deploy in the real world, one is implicitly also choosing a specific set of preference shifts to induce among users. And this could be problematic depending on the grounding of the preference space that we're in. For example, in this case, like shifting most of the users' preferences towards liking sensationalized news doesn't seem like necessarily a good thing. Okay, so I guess given this, what would be nice to have? So I guess on one side, it would be nice to have these graphs and like be able to estimate how preference would shift under different types of policies even before the policy is actually deployed, because you don't want to cause the shifts to then know. And additionally, it would be nice to evaluate whether these induced preferences are undesirable or not, and having a computable metric for that. And that would enable to actively optimize recommender systems not to cause unwanted preference shifts. So these are the goals that we build towards in this paper. So one background question is, why would we expect large differences in preference shifts among different types of policies? So should we expect these large differences? Well, for recommenders, so for recommender systems that are trained with reinforcement learning, probably yes, or potentially yes. Recently, there's been this trend of optimizing long-term value, often operationalized as long-term engagement for reinforcement learning, rather than using myopic systems. However, directly applying reinforcement learning to recommenders might lead to problems. The entire purpose of agents trained by RL is to actively modify the environment in ways in which lead to high long-term reward. But given that the environment in recommender systems includes humans, there is also a strong incentive to basically modify users in ways that are that lead to high long-term reward, and this includes their preferences, beliefs, and so on. So insofar as the system can change users' preferences and it discovers ways to do so in ways that increase long-term engagement, it will actively try to bring those preference changes about. So this has been noticed by previous work, and the solution proposed there was to try to keep recommender systems myopic and just avoid this problem entirely. However, even myopia doesn't entirely fix this problem, because these systems will still be interacting with users and influencing the preferences, the evolution of their preferences. And so you can still have undesirable preference shifts even with myopic systems. Okay, so I guess now that having argued why we can expect different preference distributions or preference trajectories across different policies, we can move to showing how we try to address this first point, or like a method for anticipating what preference shifts a policy will cause before it is deployed. So let's consider the specific user who has these initial preferences which evolve over time. These preferences in the real world are clearly not observed, but as the user interacts with the system, although we don't see these ground truth preferences, we do observe the slates that the user was shown and the user's choices. We're assuming here a slate-based setting. So the way we think about preferences is as unobserved latents, which explain behavior at every time step. So for each time step, there is a preference latent, which together with the slate basically determines the distribution of choices that the user will take from this slate. Okay, so in short, we assume that preferences are compressed representation of user behavior. So users are more likely to choose content which has higher engagement value. And we operationalize engagement value as being the product between the user's preferences and their choices. So making this assumption is basically equivalent to assuming that we know the user choice model. So given the user's preferences and a slate, we know exactly what type of distribution they will draw from when choosing content for this slate. So it turns out that having this type of assumption is actually enough to estimate preferences directly. So what we would have is this type of setup where we have slates and choices for every time step in the past, and we want to estimate what the preferences for the next time step is. And the structure of this task is pretty similar to that of a click predictor, but now the goal is to estimate preferences and then clicks rather than clicks directly. So we would feed in this previous context of interaction to a model, but instead of predicting clicks, we predict the preferences. So a distribution over preferences. A question here is like a clear question here is, how would you actually supervise the training of this model? And it turns out that if we have this prediction over preferences, given that we assume a known user choice model, we can use the information from the current slate to induce a distribution over choices. And once we have this distribution over choices, we can compare this distribution over choices with the actual choices that we have in our data set of previous interactions to train and supervise the training of this model, essentially. Okay, so at this point, we can also try to extrapolate preference trajectories from our data. So let's say that we have observational data for this user until time step 9. We can ask how different policies would impact the user going forward. In particular, we might be interested in another policy, pi prime, and we can select a slate based on pi prime for the next time step. And we can feed this in as context to our preference prediction model. And this is just the same exact problem as before, where we're predicting the preferences for time step 10. Then based on that, you can just repeat this process multiple times to obtain preference predictions for like basically trajectory completions in preference space for various policies. And based on this, you can basically compare how you expect different preferences to impact the same user. And you can do this on population levels and also in other ways that I won't be mentioning in this presentation. Okay, so I've briefly given an overview of how one might be able to anticipate what preference shifts a policy will cause before it is deployed. And now I'll briefly talk about how one could go about evaluating whether induced preference shifts are undesirable. So if we're confronted with these different types of preference shifts, one might like to evaluate whether these shifts are positive or not. It doesn't really make sense to do so without a grounding. So we could look at what this preference space actually means, and then qualitatively potentially go in and just look at these shifts and be like, okay, well, in this specific set of shifts, given that most users are starting to prefer sensationalized news, that's maybe undesirable. And just qualitatively go through and analyze these things. But this is clearly not very scalable, given that the preference spaces in practice would be extremely complex. And so it would be nice to have a quantitative way of addressing this issue. But one background question is what kind of shift do we even want, or are even desirable? So one way to potentially, one idealized way to answer this question is, well, maybe the shifts that would be induced by having an enlightened human interact with a recommender system are shifts that we would trust. And with enlightened human here, I mean a fully informed, not affected by temptation, perfect self-control, et cetera, et cetera. So if this enlightened user were to have certain shifts, well, we could trust those to be actual shifts that the user would want to have. But clearly, we do not have access to enlightened users. I'm not an enlightened user myself. Okay, first of all, okay, so once we had these types of shifts, one thing that we could do is consider the distance between the shifts that are induced by enlightened users and the shifts that are actually induced in our system. And if there are very large differences between these shifts, then we could flag these as potentially problematic. Like if the enlightened users are doing very different things, well, that's potentially suspicious. But clearly, okay, yeah, so we don't have enlightened users. The best thing that we can do maybe is to just try to remove as much influence as possible from the picture, outside influence from that is caused by the recommender system. So basically have the user explore their preferences naturally and without any external influence. So there's various ways one could go about trying to operationalize this. Some simple ways are using a random recommender system or a reverse chronological recommender system and see how the preferences evolve in that case. Or additionally, this baseline that we're considering here relative to the shift that we observe could be operationalized in other ways. For example, we could consider the initial preferences, and if the preferences change much from the beginning, well, that could be considered bad, just as a very conservative way of defining it. But really, these baselines are not very easy to define, and it should probably be more of a collective and political decision rather than one-sided. But okay, so clearly, so I guess ultimately what we're proposing is a framework for creating conservative metrics rather than a specific set baseline itself. Okay, so just to recap, I've mentioned a method for anticipating what preference shifts a policy would cause before it is deployed. I proposed a preliminary approach for evaluating whether induced preference shifts are undesirable. I have not talked about this, but once one has this way of evaluating undesirable preference shift, one could actively try to optimize recommender system not to cause unwanted shifts. So basically using RL, but with a penalty for deviating, for raising red flags. So basically for deviating from preference shifts that we trust to be safe. Thank you so much.
Should I just unmute? Is that okay for questions?
Yeah, that sounds good.
Okay, Micah, thanks for the great talk. I really appreciate that. And it's really great to see sort of a responsible AI research here at FAccTRec, you know, specifically with respect to the kind of RL work that we've seen out of, you know, David Kruger, et cetera. So really appreciate hearing your talk. So I'm kind of curious from your perspective, do you think that there is any hope for these kinds of frameworks to be actively adopted by leading social media and recommend? I mean, just going back to the panel discussion, right? I mean, we know that these preferences shifts have already happened. I guess there's sort of two questions. A, you know, can we kind of encourage the actual social media, you know, algorithms to adopt this? And B, is that even sufficient? Do we actually need to kind of undo the harm that has already been done towards sensationalized news and kind of actively move the user preferences back to that baseline where it was, you know, maybe 5 years ago or 8 years ago before we all landed in this bizarre world called social media? Right. I'm just, you know, really curious to hear your thoughts.
Yeah, great questions. I mean, so for the first, I don't know, I'm hoping to work on extensions to this project that actually work with real user data and I don't know, could be potentially somewhat scalable to real systems. That's yet to be seen. But yeah, so that's my hope. But I guess for the second question as to whether that's enough, well, I think it's hard to say. I in a sense, like even if one were to use this type of system, there's still like a lot of questions of how you would define baselines, what is considered okay preference shift, and so on. And that's like a whole like very difficult problem to address.
Then you're in the realm of interventions rather than just recommendations.
Right. Yeah, and then retroactively fixing harm, well, that would be like great. Yeah, but it seems also complicated. Yeah, so I don't have, yeah.
Would love to talk more offline about this work.
Sounds good. I see another hand. Sure.
Yeah, just a quick comment on that, Micah. So thank you for the presentation. It reminds me actually of the project that we did in Belgium many years ago, starting 2015 with the public broadcasting or public broadcaster in Belgium. And I'm sure that the BBC, two colleagues, previous colleagues from the BBC would be also interested in that. But I found that it was actually very difficult to sell that idea of, trying to give an orientation to the recommender system and to move people from things that are sensational to things that you judge as being acceptable or more acceptable. It becomes more paternalistic, and people were not really open to that. Actually, the public authorities were not open to that at all. So we had to fight back, and we basically never find a solution for that. So I'm very curious about what you are going to do as a next step to test that system, and whether you have undergone or taken such steps already.
Yeah, so okay, one thing that I would like to just clarify is, so this axis of like this instantiation of how I grounded the y-axis in the preference space of sensationalized news versus dry journalism was just like an arbitrary one. Like I could have, like other things could have been like conspiracy theories versus, or I don't know, no vax or something. And I think like in some of these axes, it's more clear, like, or I don't know, preference for like abusive language, I don't know, something like that. Like, I think it's more clear and it's easier to argue that this is like bad or something. But yeah, I agree with you that it's like there's always a paternalistic component to it, and it's unclear what the line is there.
So let's change a little bit the y-axis to something different, and we take the example of Deng from TikTok just before you, and we change that y-axis and we say that the upper scale is amount of time consumed, and we want to reduce the time consumed, which I think may be something desirable for parents seeing their children spending hours on TikTok. Do you think that is acceptable? That's a question actually that I asked to Deng, but that was not answered. Is that a measure of fairness for ByteDance to reduce the time consumed on TikTok?
Yeah, I guess like, I don't know, at least in our framework, that would be equivalent to defining what the baseline is that you're comparing to, like what is the desired preferences, right? And I think that seems to me like, yeah, a decision that should be made like collectively somehow as a society. I don't know exactly what the best way to do that is, but yeah, maybe like a participatory approach of some kind. But yeah, that's my own personal opinion there. Yeah. Polina?
Hi, thanks very much. That's a really interesting research. I was wondering, this question of tension between paternalistic approach versus following the user is very important. That's true for BBC as well. I wanted to ask something else. I was wondering how much research is out there generally on preference shifts. I'm aware of Spotify research on that, which I think is very interesting, where they track users' preference changes in terms of microgenres that people listen to. And in that case, you would assume that there is nothing, so that there's no axis that would be in your sense would be undesirable, but you could think of maybe in say in context of Spotify, you might think of situations where user changes from consuming more long tail content to more popular content, and that could be something to watch for, at least whether that has been caused by any policy changes and so on. So I guess my question is about general preference shift research out there and how much of that went into your work, because I don't know much about it.
Yeah, so I feel like, I think there isn't a lot of research as far as I've searched like background work in this area quite a lot, and there's only like a bit in economics, philosophy, and I think there's some like works in the recommender system space that yeah, definitely fall into that, like the Spotify work and like others that are a little bit more tangential. But yeah, I think like generally it seems like just using RNNs as click predictors is as close as it got to consider, or I mean, I don't know, there's some other like matrix factorization approaches that consider changing preferences and so on. But yeah, I don't know if I have a good answer to that, really. Yeah. But yeah, in terms of the Spotify non-normativeness of the y-axis, yeah, I totally agree. Like, it seems more like yeah, for the Spotify case, I mean, you could still use this method to like have insights on what kinds of changes that your policies are inducing, but it's kind of less clear, I mean, if something is undesirable or not, at least from a societal perspective. Yeah.
I think we should move to the last paper, right? Because we're running out of time.
Yeah, sure thing. Yeah. Hopefully you can see my screen. Awesome. So thanks everyone. And thank you actually, Micah, for that lead in, because I've actually worked on something very, very similar, but hopefully it can be different enough to keep us interested for the next few minutes. So our talk is on, well, I'm Charlie, my co-author Otusa is also here, and our paper is User Tampering in Reinforcement Learning Recommender Systems. So basically what we want to talk about today is the effect that Micah has described here, which is this idea that if we have these reinforcement learning agents attempting to maximize click-through or engagement or something like that, then the idea of changing the user's preferences so that they become more predictable becomes like a desirable thing to do from that perspective. If we take this as like a real effect, obviously it's serious and it's distinct from things that we see in things like filter bubbles, because not only is a user being trapped in sort of a prism of their own preferences and their own opinions, but they might actually be forced in a certain direction. And so in slightly different spaces, hopefully what we've been doing is firstly sort of trying to formalize this effect using causal modeling, and also sort of doing a couple of simulations, just seeing if we could sort of draw out this effect in some simulated users. So causal influence diagramming, which is something that's been developed quite recently for modeling causality in decision-making programs. And so these are basically directed graphs with three different types of nodes. So we have structural nodes and utility nodes, which are both sort of random variables that will represent either sort of, state of the world or like a reward respectively. And we'll also have decision nodes, which aren't a random variable, but are actually just like a point of decision in the problem. And so we're also going to have causal links between these nodes represented by directed edges. If these edges are going into a structural or a utility node, that's saying that the value of this variable is dependent on the source. Whereas if we're dealing with a decision node, this is saying that we're going to account for this information in this decision. And finally, down the bottom, as you can see, if we have a path like the following, where we just start at a decision and we end with some utility node, and this path is going through a structural node, what we get is what's called an instrumental control incentive on that structural node, which basically just means there may be an incentive to like shift that distribution in a certain way with the action if we can. And if we want to do that in a certain way to get more reward, there is an instrumental goal to do so. So what we did with this was basically look at the recent research in RL-based recommendation and see what sort of a causal structure is implied by the MDP models that these papers were using. And so it looked something a bit like this. So we have our structural nodes at each time step, so x plus 1 and so on. And at each of these structural nodes, we have like a distribution over information like recent recommendations, success of recent recommendations, and context and so forth. Whereas our actions are going to be recommendations, and everything holds that I've just said. So like our recommendation will be based on the state of the world, and the state of the world and our recommendations will determine the next state of the world and so forth. However, what we argue in our paper is that this isn't really a sufficient causal model of the problem, because as Mike has alluded to, we actually have these sort of exogenous variables, which we call theta t, which are basically representing something like the user's preferences or opinions or beliefs. So even though the algorithms aren't explicitly modeling these, what happens is they still sit in certain causal relationships with the MDP. So we can see that each recommendation will affect the user preferences at subsequent time steps. The user preferences will affect state transitions subsequently, because they will affect the value of metrics like which recommendations have had success recently. This creates an instrumental control incentive, as we discussed on theta t, and therefore if we can shift theta t in a certain direction that will make recommendation easier or more predictable, we have an instrumental goal to do so. So this basically gave us certain definitions that we gave in our paper to say that this effect, which we called user tampering, is learnable if there is an instrumental goal to affect the user's preferences or opinions or beliefs. And it's being exploited if the recommendation policy would have been different, like under different circumstances, basically if these causal relationships didn't exist. So moving on to the next sort of segment of our paper, we basically just wanted to do some basic simulation of this effect and see if we could have a reinforcement learning agent attempt to polarize some simulated users. So our setup was basically just, we had 3 different sources of content. So these could be 3 like news publication sources, and each one had a different sort of political leaning, so to speak. So there was a consistently left. The recommender just needed to make T consecutive recommendations, where this just meant choosing a source and assuming that there would be an article ready to go from that source. And so the goal was to maximize engagements, where engagement was just a binary yes or no from our simulated users. Our users were simulated as basically just a preference profile over these 3 sources, but also in terms of like a probability that they would sort of built in to make this problem interesting was a dynamic that was observed in recent research at where basically if we had social media users that aligned with a certain wing and they were recommended a lot of content from the opposing wing, this actually tended to drive them further direction. So we simulated this by having users increase their propensity to click on their favored wing if recommended content from the other wing by a small randomized amount. So we had results for a whole different population of users that we trained this algorithm on and evaluated it against. So to speak, under our simulation. And what you see is down the page, we have our time steps, and in each row, we have the relative frequencies of recommendations that were made to the user, averaged over like many episodes of this. And so what you basically see is that in the early time steps, it attempts to profile the user. So it makes some centrist and some left-wing recommendations to see if it can work out sort of who it's dealing with, so to speak. And then you can see a really obvious it's actually recommending right-wing content to this left-wing person in an attempt to exploit that I've just described to you before it actually switches back to predominantly left-wing recommendation to capitalize on this. And so basically what we took from all of this to summarize is that manipulation by reinforcement learning based recommenders is formalizable and it's feasible. So this has implications beyond the political. Obviously, we have focused heavily on polarization in our simulation, but this has implications for recommendation more broadly. But by user behavior seems to sort of unavoidably permit this. We go into more detail in our paper, but just basically the causal structure of the problem, once you start defining reward in terms of observable behavioral signals, becomes very tricky. And finally, more work is needed in the mitigation strategies, in regulation, in awesome work like what Thank you very much. So I'm just heading back to the Zoom, but in the meantime, if anyone has any questions, fire away.
Hi, Charles. Still speaking.
Yeah.
So thank you for the very interesting talk, and also the talk from the previous presenter. And you're addressing the same problem user preference shifting, and I wonder if the intervention methods that you have described, they would have different impacts to different groups of users. For example, active users and users who are not so active, and so on.
I mean, yeah, I think that's definitely possible. I mean, I'll leave the door open to Micah also answering, given that sort of applies to both of our topics. But I think something that we sort of observed in our causality work is that the fundamental issue here is that because these algorithms don't explicitly model things like preferences, it sort of ends up with a skewed sort of view of the transition function as representing something that it isn't, because in our example, if you end up in a situation where you've recommended a lot of right-wing content and you haven't gotten a lot of engagement, you're only likely to end up in that sort of area of the state space if you're dealing with a left-wing user. And so that you build sort of a skewed perspective of what is a good thing to do in that state space. So to answer your question, I think that is definitely possible, just in the sense that what is missing is sort of a greater understanding of the actual causal structure of this problem. And so what might happen is that a reinforcement learning based recommender might end up with sort of a bad policy, or a policy that we don't want, because it represents what the majority of users that end up in that state space might want. So I hope that sort of reflects what you're saying there. Like, it might end up having a certain effect on users who are very active versus users who aren't, for example.
Toshiro, how are we doing in terms of time?
In my understanding, you were chair of this session. In my understanding, you were chair of this session.
Okay. I was chairing actually the next session, session number 2, right?
No, the next session is nothing.
Yeah, next
Okay.
session is me. I think maybe because we spent some time in the panel, maybe we can shorten the, as also Toshiro suggested, maybe we can shorten the break to 15 minutes and come back.
Okay. Okay.
Let's start the next session in 80:30. 70:30.
Okay.
Yes.
Okay. 17:30. Okay.
So we have a short break of 20 minutes and we meet up here again in 20 minutes, right?
Yes.
Okay. Thank you.
Hi, everybody. Welcome back to our next session. Venshuo, do you have your slides ready?
Hi, yes.
Okay, so you can start when you're ready.
Okay. Can you see the slide full screen?
Yes.
Okay. Should I start? Okay. Hi everyone. I'm Wenshuo from UC Berkeley, and today is my great pleasure to present this recent work with my collaborators Carol, Michael, and Nikhil for this paper. So the problem here we are considering is the stereotyping problem in collaborative filtered recommender system. So as we all know, there has been a lot of wide applications of recommender systems, especially for a lot of online platforms. So recommender systems are really like mediating our access to a lot of online information and play a crucial role in online platforms. And in particular, matrix factorization and collaborative filtering techniques have been very commonly used in practice. So a few applications here include news recommendations, online advertising, or like recommendations on like music platforms. So yeah, so here, because of those wide applications, it's really important to consider if these like access to online informations are actually fair, diverse, and in the proper way that we want it to be. So let me quickly go over some basics of collaborative filtering techniques. So the basic idea here is really to capture user preferences and item characteristics based on the principle of the similar people like similar items. For example, there could be the user-based filtering or item-based filtering. And one example could be if two people, Bob and Alice, both enjoy item 1, and Alice further enjoys item 2, then Bob is very likely to also enjoy item 2. So based on this simple principle here, collaborative filtering is really assuming that these preferences are transitive. So in this work, we are really considering what can go wrong here with this idea. So because we are assuming the preferences are transitive, implicitly, we are also assuming that negative preferences are also transitive. For example, if in this example, Bob and Alice both enjoy item 1 and Alice doesn't like item 2, then the collaborative filtering technique would also assume that Bob is not very likely to like item 2. So in this case, the CF-based technique is also restricting Bob's access to item 2, even if Bob likes this item. So that is why we are calling it a stereotyping problem here. So suppose a user prefers a set of items that are anti-correlated in the broader population. Then these items are unlikely to be jointly recommended to this user, regardless of that user's preferences and ratings. And especially this problem could be more exaggerated for cultural minorities, in particular if other users do not like their culture-specific items. So to formally characterize this problem in this paper, we are formulating this idea called joint accessibility. So really this joint accessibility is trying to capture the possibility of a joint set of items to be recommended together to a user. So in this case, we're asking, is a user able to access or recommend it to any combination of top K items in a top K recommendation that they might like. So in this work, we formally introduced this notion of joint accessibility and study the geometric interpretation of it, and also studying the joint accessibility under the standard single vector representation for each user and necessary and sufficient conditions for it to hold. And after that, we also proposed an alternative modeling fix for the single vector representation. And we also conducted some experiments on real and simulated data sets. So let us go over what's the formal definition of the joint accessibility. So let's consider a top K recommendation to a user with a total set of n items. In a standard matrix factorization model, every item will be associated with a unique feature vector, denoted as Vj here. And the user will also be recommended by a feature vector, denoted by U here. And the score or the predicted rating in the really simple case is just the inner product between these two vectors. More generally, this could include also user and item biases, but here we're just consider the really basic case where the score is computed by the inner product. So in a top K recommendation, the recommender will simply select the top K item with the highest score. And here we will consider a recommender system satisfies joint accessibility if and only if basically for any set with size K in this item set, it is true that there is at least one user vector where this S could be recommended. So we'll really consider the user vector could be any vector in this feasible space. And is there a user vector which this item set could be recommended as at least? So a given set is joint accessible if there exists at least one user vector such that this set S is recommended. So what are actually some interpretations for this definition? So the first way to look at it is to view this problem from the convex Hall perspective. So in this right picture, we're showing 4 items here, and the green vectors are denoting the sum of 2 items together. So for example, the green vector 1, 2 denotes the sum of feature vectors of item 1 and item 2. And in this case, it turns out that a pair of items is accessible jointly only if their sum feature vector is a vertex of this convex Hall. So clearly we're seeing that here the pair of item 1, 3 and the pair of item 2, 4 are not accessible here because they're inside the convex Hall and not being a vertex. And the second way to interpret this definition is through a notion called Voronoi diagram. So if we consider all the item feature vectors are normalized with unit 1, then basically an item in a top 2 recommendation, only the Voronoi neighbors are jointly accessible. So here on the right side, in the figure, each cell is denoting the Voronoi cell for each item, which basically contains all the vectors which are closest to this item feature vector. And here we can see that item 1 and item 3 are not neighboring in terms of the Voronoi diagram, and they're actually not jointly accessible. So after that, we are showing some, so what are the joint accessibility with the single vector representation? And we basically tested this with some synthetic data sets and also the movie lens data set. So in the synthetic data set, I will skip some of the details here, but basically we constructed a synthetic rating data set where there are 20% users are minority users. So these users are having a combination of 2 interests over 2 topics, which are not the same as the majority users. And here it turns out that it is indeed true that not all the item pairs are accessible, even if there are users who like these pairs of items. So on the right side, we can see that the fraction of item pairs which are accessible is much lower than the Oracle recommendation. And on the other side, if we consider the combination of interest between the majority set of users and the minority set of users, we can see that. So here, basically, the values indicate the fraction of item pairs for each topic pair that are recommended together for a user vector. And basically, these very low values with the dark colors are the combination of a majority interest plus a minority interest. So these are like basically saying for a minority user, this user has an interest which is not the same as the majority user, and this interest is basically not captured in the recommendations. So really the main message here in this work is to introduce this joint accessibility notion and also show that the standard CF-based recommendations with single vector representation can actually provide a poor joint accessibility. And this is in particular exaggerated with minority groups. So for future work, we would like to consider new training algorithms for different representations, such as multi-vector representation or alternative model or recommender heuristics. So with that, I will conclude my talk and thank you for listening.
I think there are some comments and questions in the chat.
I see. Oops, okay. Okay, I'll just go over these questions one by one. So the first one is, the transitive property is limited in the case of implicit feedback. Yeah, I think that is a very good point. So yeah, I think it is true that for implicit feedback, the transitive property is less direct compared to considering these like direct like rating feedbacks for sure. Yeah, and we haven't really experimented much with the implicit feedback side, but that's a really good point. And the other question is, does the single vector representation apply to representation of the item or the user, or both? Yes, so the single vector representation here is both for the items and users. So, and indeed, actually in the paper, the proposed alternative fix here is to represent the user by a multi-vector instead of a single vector. So basically, we think the problem is really about representing a user by a single vector, which geometrically limiting the access to some diverse item set. And the third question is how to identify minority users. Yes, so that's a really good question. So in terms of this data set, because we are constructing it synthetically, mainly because with the synthetic data, we are aware of the ground truth preferences of each user. So specifically for this data set, the minority users are like just known, and we basically constructed them during the generation of the data. But in general, we also did the same plots with the movie lens dataset, and it's really just bioheuristic where to consider the top one or top two topic preferences for each user and just manually calculate which set of user is more having the minority preferences. So I think it's a bit more complicated with real data sets, but with the synthetic data, we basically know the ground truth. Okay, are there other questions or?
I think we can wrap up and go to the next presentation. Thank you very much for your presentation.
Thank you very much, everyone, for the great questions.
I am going to get started, if that's okay.
Yes.
Hello, I'm Emma. I am a PhD student at the UC Berkeley School of Information. Today, I will be presenting some work I've done with my advisor, Deirdre Mulligan, searching for representation, a socio-technical audit of Googling for members of US Congress. Okay, there are a lot of words in that title, so I thought I would start off with an example. I moved to Berkeley about 2 years ago now, and shortly after I arrived, I searched my zip code plus congressperson to see who is my representative. The top result let me know that Jerry McNerney is my member of Congress. I've seen a couple other Berkeley students today in this presentation or in this workshop, so maybe they already know that that's actually not the congressperson for Berkeley, California. It's actually Barbara Lee. This is problematic and inspires the rest of this talk. But before I dive into how I understood the scale and cause of this problem, I think it's worth taking a moment to discuss why it's important to know who your member of Congress is in the United States. So one reason you may want to know your member of Congress or contact your member of Congress is to navigate federal bureaucracy. So if you're not getting your Social Security check or struggling to access veteran services, need embassy help, these are all things that your congressperson's office could help out with. Another reason you may want to reach out to your congressperson is to encourage them to vote a particular way on legislation or a confirmation vote. And frankly, it's a pretty basic piece of civic information. But I also think this case study is interesting for this particular audience because, as was surfaced in the panel discussion earlier, we have these kind of complex normative questions that arise when we talk about political bias, about what are we actually looking for. But the identity of your congressperson for a given geographic location is uncontested political information. And so I don't think the same normative stumbling block exists, but some of the same questions about responsible recommendation do persist. Okay, so just to be clear, it's not just me who has tried to use Google to find the identity of their congressperson. I put up one tweet that talks about finding your congressperson to let them know how you feel about Supreme Court Justice Brett Kavanaugh from a couple of years ago. And I just picked one tweet, but there's many of this ilk. But the thing to know methodologically is a lot of times when we talk about Google search, the first reaction is to go to Google Trends. But for something as highly localized as a geographic query based on your congressional representative, there just isn't enough data to have meaningful results from Google Trends. Okay, nevertheless, how big of a problem actually is the incorrect name showing up on the top result of Google search? Well, here's just another example of queries I did in subsequent days for, again, the name of your congressional representative, 2 different days, 2 different search results, both are incorrect. But the thing I also want to draw your attention to at this point is the circles in red, which indicate that these search results aren't just the top organic search result in Google search, but are featured snippets, right? They show up at the top of the Google search result page in kind of a way that says, hey, here is your answer. Sometimes these features are called quick answer boxes. I think this is significant because it really is very misleading when they are incorrect, because the idea is from these search results that you don't have to click on any external page. Here is the information you need, and then you're kind of done. But the other reason I think it's interesting to follow or to focus on featured snippets is that Google has different policy standards for civic information as well as health information. In particular, when a featured snippet is incorrect for this type of information, they commit to removing it. This is, of course, different from organic search results, where Google has historically shown an extreme reluctance to remove inaccurate search results. Okay, so in this study, I aim to understand the scale and the cause of misleading search results identifying individual members of Congress. I've included some spoilers in case your interest fades, but I want in this talk to share with you about what I found about how common this problem is and why I think it is happening. There's a lot about methods in the paper because what I've done is a little bit non-traditional and I think interdisciplinary in kind of an exciting way. But basically what I need to do first is identify a set of search terms that capture the breadth of how information seekers search to identify their congressperson, and then programmatically put those search terms into Google search. And then we need to develop a set of criteria for what is misleading or incorrect for Google search results with regards to this topic. And then we need to do some form of analysis to understand how often that is occurring. Okay. In the literature, picking what queries to audit is actually relatively complex and fraught. For this paper or for this study, I actually did a survey to ask people what they would search, and then just kind of created templates out of their response, and then filled it in for a bunch of zip codes. This paper, I just talk about California, but there's more work to come about all of the United States. I think California is a relatively strong proxy for reasons I'm happy to talk about in QA and in a Q&A, but also is detailed in the paper for the other US states. Is in actually many ways probably a best case scenario for having the most accurate results. Okay, but I think something else that goes back to the panel this morning is thinking about how to kind of formalize this idea that errors aren't evenly distributed, or like what are we optimizing for or trying to measure. And so instead of just talking about inaccurate top results, I actually choose this frame of likely to mislead a reasonable information seeker, which doesn't come from anti-discrimination law, but actually comes from consumer protection law. This idea that something is deceptive or a trade practice is deceptive or unfair when it's likely to mislead a reasonable consumer in that case. Yeah, so some of these search results are incorrect. Like if you look 03227 congressperson, the top result is Henry Clay. If you're caught up on your US history, that's an 1850s congressperson from New Hampshire. That's not correct. But then even more common is when users put kind of overgeneralized queries for this topic into search, they get generalized results, right? Like Nancy Pelosi is a representative in California, but not the only. So it's not accurate, but it's not misleading. And so we don't count that as a misleading search result in this study. But of course, this first example that I did show you is misleading and would be counted in the study as so. Okay, this was kind of the overview again of what we're doing, but now kind of going into the analysis, what we found. Yeah, so over half of the top results, so being that first result on the search engine result page, are featured snippets. 16% of the featured snippets are misleading, and 60% of those misleading feature snippets are from Wikipedia. And then 12% overall of all top results are misleading, including featured snippets and non-featured snippets. Okay, so why is this happening? This is what the congressional or part of the congressional map looks like for California. It's a little hard to tell from this diagram. There's some GIS work in my future to make a prettier one, but basically what I'm trying to show you here is that city lines and congressional lines are not, they do not perfectly match. So there are cities where they span multiple congressional districts, and so geography and geographic ambiguity is a part of the problem here. So for example, this is Scott Peters, shows up as the top result for this query, but actually San Diego has 5 congressional representatives in it, but Scott Peters doesn't even represent the majority of San Diego. He is just one of the representatives. So why is Wikipedia turning up this page? I think there's a bunch of reasons. Perhaps kind of the most surface level is that in Scott Peters, or in the 52nd Congressional District page, and Scott Peters is the representative for the 52nd Congressional District, the term San Diego appears 7 times in the first 3 sentences, which is basically a keyword stuffing, kind of signaling to Google, or unintentional keyword stuffing of making this seem like the best result and the best metadata to feature in that featured snippet. The other interesting thing about these queries is a lack of machine parsable data. So this is what Nancy Pelosi's website looks like when trying to understand what areas are in her district. It is a map. And for people going to their, her website to find out who is in her district, this may work really well, but it doesn't for search engines. So often when I talk about this topic, everyone's really excited to use the word data void, and data voids are, a fun topic to talk about, maybe not in actuality, right? but it's not really a traditional kind of data void because every member of Congress has a house.gov webpage, has a Wikipedia page. Every congressional district has a Wikipedia page. But what we're seeing is that these sites aren't optimized for the queries that users actually search. I just want to talk briefly about a couple ideas for how this could be fixed. One is Google actually already has a API that helps developers display civic information. They're just not, to my knowledge, deploying it for queries like this. So really the metadata is already actually there. It's just not being deployed. Two is improving these existing lookup tools that, again, are fine for users who actually navigate to those sites, but helping feed those into Knowledge Graph and other kind of ways to make that data more legible to search engines. Yes, thank you so much. I'm really happy to discuss this topic more. To be frank, this paper has gone a couple rounds and seemingly hasn't caught the interest of more technical venues. So I'm really open to all and any feedback.
Thank you for your great presentation. I think you have a couple of questions in the chat.
Yeah, I will start, I hope, at the top. Is outdated information also one of the major causes for misleading results? Yeah, that's a great question. So the short answer is no. So if we think there's like two ways things could be outdated, one could be congressional redistricting, right? Like the district lines are redrawn and it's just showing past data. Another is like someone was the representative, but they've retired or are no longer in Congress. And maybe we'd see that if like Wikipedia pages weren't updated. Neither of these were really key causes that I saw. Again, like maybe it would be interesting to rerun the study in a year as the congressional boundaries are redrawn. But in the status quo, no, we did not see a lot of that. It wasn't that Wikipedia pages weren't updated. It was just that the right Wikipedia pages weren't being surfaced, or that Wikipedia pages aren't really designed to surface that kind of information. Yeah, it's an interesting. Code for America is a great organization. I think that would be interesting. Do Congress people advertise on search engines? Another great question. Ads really were not common as a top result for queries like this, right? So we see a lot of advertisements around elections in the United States, right? Though there's like, again, increasingly technology platforms have complex policies around advertising, but there isn't advertising money put in to helping constituents access the services of their representatives, right? It's more advertising to get you to vote. So anyways, so I don't see that a lot in the search results. There's very few advertisements showing up. And then I'll take the last question and then I'll go to hands of how much blame or responsibility would you attribute to Google's hubris in attempting to answer a user's question in the first place? Yeah, I think, I don't know what the answer is. I will say, and I don't, yeah, I've talked to Google about this problem and they have made it better since the original paper came out. But I do think there's a question about like whether the existing knowledge graph that feeds these featured snippets is the right tool for all queries, right? If some kind of specialized expertise or some specialized sources should be surfaced for these kinds of queries. Yeah. Okay, I will take, if I have time, do I have time to answer the hands or no?
Yeah, so we can start with Shiri, the person who raised her hand.
Yeah, Emma, great talk. I know you mentioned it made the rounds. Well, you know, don't take it personally. Sometimes papers get rejected for all the wrong reasons, and you know, there's a lot of noise in the process. But I personally greatly enjoyed your talk, and you know, I think it brings up a really important question with respect to, again, accountability of like, this is a data void that you're pointing out that has very real impacts. I kind of mentioned it in the chat, but another use of elected officials that you didn't call out as using them in your citizenship test. And so if you actually get it wrong because you Googled it and you Googled it incorrectly, then, you know, that's a problem. But I'm interested because I remember when I took my US citizenship test, you know, I used there's all these apps that do the test for you, and they basically ask you, and I can't remember if they were asking me like, what's my zip code, and they filled in the representative, or they basically asked me like, who is your representative, so that we could quiz you on it. But I'm just trying to reflect on that, and I'm like, well, that would be really crappy if, you know, if I Googled it, got the wrong answer, and then got it incorrect on the test because of that. So, you know, just super, super interesting. And I think, you know, I'm the one who mentioned Code for America, not necessarily saying it should be a civic, you know, like nonprofit responsibility. It absolutely should be Google's responsibility. But, you know, I think that it's a very interesting gap that you've identified, where the data is there, it's just not in the right format, and Google doesn't necessarily, I'd be curious if you found, where's the wrong data coming from? Like, do you have any indication of, you know, maybe I missed that in one of your slides,
Yeah,
but
no.
Was there any clarity for you on, like, because you were showing 3 different names of 3 different representatives, all of whom were wrong. So I'd be really interested to hear how do you think that came about?
Yeah, I think, you know, it's a longer conversation, but briefly, I think Wikipedia, and there's a well documented literature about Google's reliance on Wikipedia for knowledge graph and search results, like, you know, at the top of the SERP. And Wikipedia is amazing. This is not a slight on Wikipedia, but Wikipedia just isn't designed to answer these types of queries, nor really should it be. But nevertheless, Wikipedia pages are surfaced more often than not. And then the congressional representatives' pages that do list specific zip codes on their site, even if they aren't the totally correct zip codes, also seem to be preferentially treated. So it's just kind of these funky, it's not, you know, disinformation or anything intentional, though perhaps it's ripe for exploitation from certain imagined bad actors. Yeah, but that's what kind of I've seen happening so far.
And sorry, just a quick follow-up, and then I promise I'll hand it over to somebody else. But did you notice that, was there any bias towards women being incorrectly identified, or did you kind of anything?
Yeah, so I looked at
minorities, et cetera.
Women, racial minorities, so the sample size for that is obviously too small to say anything too certain, urban versus rural districts, and a whole bunch of other things, and found null results. So nothing to say along those lines.
Well, at least that's a relief. They're not discriminating against the false results.
Pierre, did you have a question? I also saw you raise your hand.
Yeah, I had a question, but I think we need to move on to. So just want to. I will post my question in chat.
Yeah, you are more than welcome to stay in the break and discuss more about this paper.
Sure.
Yeah. So Shiri, I think you're up next.
Yes, that's right. Let me share my screen. Of course, that's assuming that I will find the right window, because of course I had it here a moment ago, but now it's not here. So give me just 1 second. Thank you. Can everybody see this all right? Okay, great. So thank you, everybody. It's great to be here. My name is Shiri Doria-Cohen, and I am an assistant professor at the University of Connecticut, where I lead the newly launched RIGHT Lab, Reducing Information Ecosystem Threats. And I'm also, up until recently, was the CEO of OCODE. I'm now the board chair, startup that reduces misinformation and controversy online and turns it into actionable intelligence. This paper, Fairness via AI, Bias Reduction in Medical Information, I'm pleased to present it on behalf of multiple colleagues that I've had the pleasure of collaborating with, including from several medical schools, as well as nonprofit. And one of the other speakers is here on the line, Fabrizio. So thanks, Fabrizio, for joining us today. So I want to point out an aspirational gap in fairness in AI efforts. So on the one hand, here on the right-hand side, every day we're bombarded with news and blogs, posts on social media about an increase of attention paid to racial gaps, gender gaps, sexual harassment, and a strong desire to reform society for the better. And on the left-hand side, we have academic papers about fairness in AI, trying to improve modeling and trying to make sure that we don't have algorithmic bias in our systems. But these, the way I think of it is like never shall the twain meet. There's a gap here between the world that we're trying to build, which is a more equitable and less biased world, and the fairness in AI literature. And the way that I think of it is that our standard AI practice is, we take reams of data, feed it into AI models, and we get recommendations, predictions, classifications, a variety of outputs. And in fairness in AI research, by and large, what it does is it observes the recommendation and predictions and says, is there bias? And if so, can we fix it? Occasionally, it moves the magnification glass over to the AI model itself, but the results are very similar. However, the problem is that this is an inherently limited model. As Sandra Mason points out, there's a bias in, bias out principle. So most of us are familiar with garbage in, garbage out, but bias in, bias out is the same idea. Since the world is biased and the data that we're feeding into our models are inherently biased, then there really is just a limit, and the bias that we receive out of it is just, and to some extent, it's not the algorithm's fault or even the particular data set's fault, but rather it's the world is biased. So it's a form of a Sisyphean task, and I believe that we are facing an upper bound with these kinds of approaches to fairness in AI, which is that we're bound by the inequities that exist in the real world, and so we're limited in how far we can take these traditional being a relative term, since the whole field of fairness in AI is very new, but these approaches that are currently in use. So in this position paper, we are proposing a departure from this standard fairness in AI model, and we're calling it fairness via AI. We're rooting this in insights from my colleagues from medical education, sociology, and anti-racism. And which, by the way, ties into the link that Michael sent during the panel. And it takes a very broader lens on fairness. We're kind of zooming out from AI work per se to have a greater aspiration. Instead of just trying to fix our models, we can actually use AI to study and remedy inherently unequal situations in society. And we contend in this paper that this will actually accelerate progress and debias the world, not just debias AI. So we also coin a new term in this paper, which we call bisinformation with a B. So along the lines of mis and disinformation. And with bisinformation, we're referring specifically to the notion of biased information. And this is a unique and challenging aspect of the information landscape that, to the best of our knowledge, has not been studied on a large scale before. And specifically in this paper, we're focusing on the intersection between medical information and biased information. However, there are definitely overlaps to misinformation and other areas of the information ecosystem more broadly. So as a case study for the fairness via AI framework, we are considering the case of bias in medical information. So it's well documented, and there are many references in our full paper, that bias and language misuse can have detrimental impact on patient outcomes. Inappropriate language or social identifiers can be harmful even if they're strictly true. So just to give one example that my colleague, Roberto Montenegro, MD, PhD, often refers to is, for example, if you are teaching medical students and you say something like, well, diabetes is more prevalent in African Americans. Well, strictly speaking, that is true information. However, if you just state that as a fact, without accounting for what's called social or structural determinants of health, such as systemic racism, income inequalities, things like food deserts, availability of healthy food, etc. You are actually reinforcing stereotypes of Black people as being unhealthy, perhaps not caring for themselves well, and you're kind of avoiding. You're essentializing race as a category, even though it has no biological implications in and of itself. And of course, this becomes even more harmful when that information is actually false. So one example is the long debunked salt gene hypothesis, which is this kind of, I believe it's a 19th century hypothesis, or maybe early 20th century, that said that Black people get more hypertension because the slavery, selectively preferred people who were able to retain salt, and therefore the people with hypertension were kind of selected to survive slavery. This is completely debunked, so please don't learn from this story anything other than the fact that long debunked hypotheses like the salt gene hypothesis are actually still taught in medical schools today, if you can believe it. And of course, this has immensely harmful outcomes on patients. So we've embarked on a project that's not covered in this paper, but we just recently got a grant for several of these colleagues to reduce misinformation or biased information in curricular content in medical schools. And as my colleagues point out, this is critical for the practice of accurate evidence-based medicine. And reducing the biased information, the misinformation in curricular and assessment content is a manual and extremely time-consuming effort with immense downstream impact if we can make it happen. And our grant is focused on using state-of-the-art AI and NLP in order to scale up the detection of biased information in content, flagging it for manual review by the professors that are teaching these courses, and possibly even suggesting alternatives for them into how to rephrase their language to be more equitable. This is a non-trivial problem to get data for, so without getting too deep into the weeds, I'll just show you briefly this medical experts annotation guideline. And this is a guideline that's been used to this date by medical students and above. So you and I most likely would not be able to annotate this data appropriately because it requires quite a bit of domain knowledge. But my colleagues have successfully collected a really amazing data set of tens of thousands of individually labeled sentences with social identifiers, inappropriate use of language, bias or potential bias, as well as situations where the social identifier is mentioned in a non-biased way. Of course, this information is not limited to educational content. It can also be disseminated online, and often is. This can have negative effects on historically underserved populations, while at the same time reinforcing stereotypes about them by other groups. And recommender systems play an outsized role in serving up such content online. So reducing bias in these systems is challenging, and we can't do it unless we understand the underlying mechanisms that lead this information to be disseminated and perpetuated. So here are some guiding pillars that we propose, and I know I'm kind of running low on time, so I'll try to speed through these. And of course, the full version is in our paper. So number one, fairness via AI, we argue, is a more effective and impactful approach than the quote unquote standard fairness in AI approach. And transdisciplinary collaboration is critically needed in order to effectively and ethically study these challenges. Furthermore, biased and false information interact in complex ways, and we need a lot of careful study in order to reduce these bias in both recommender systems as well as the systems that rely on them, such as search engines and social media. I will leave you with several open questions that we posed in our paper. First of all, what are effective approaches to identify societal problems that are in most dire need of fairness via AI work, and that lend themselves to this kind of framework and solutions from that framework? Secondly, which existing and or novel AI approaches need to be deployed and developed in order to address these issues? And how can we encourage collaboration to leverage insight from other fields and infuse our fairness research with them? And finally, an open question with regards to misinformation specifically. First of all, how and where does it spread online? Is information distributed differentially in diverse groups? And which categories or types of bis and misinformation are most harmful and therefore deserving of the most diligent fact-checking and counter-messaging effort? So to summarize, we introduced a fairness via AI framework and the term misinformation, specifically in health. And in closing, I want to encourage you to think bigger about your fairness and accountability efforts. Channel the efforts to make the world fairer, not just AI fairer, and collaborate with experts outside of CS. Learn from them. They have a lot to offer us. We shouldn't assume that we know best. So with that, thank you so much, and I'm open to your questions. So let me pull up the chat. I saw there's perhaps, oh, this is Emma's comments to Emma. So
yeah, so before we start the questions, so technically this is going to be the break. So you're more than welcome to take the break, and we will come back in 15 minutes. And you're also more than welcome to stay and ask your questions and listen to the discussion right now.
Yeah, I think Emma, go ahead.
Yeah, sorry. I was hoping, this is great, really interesting stuff. I was hoping you could talk a little bit more about what you felt was missing that misinformation, the term, helps fill.
Sure, absolutely. And so if I kind of go back to this slide with the Venn diagrams, our colleagues from social justice and a medical perspective point out several problems that are not accurately covered by misinformation as a term. So for example, the conflation of gender and sex, whether that's in medical settings or not, we see that, if you've got your radar on, you'll spot this all the time. People will mention, a question like, hey, what's your gender? And the options will be, male, female, and maybe even they'll have a non-binary option, but they're conflating male and female, which are sex terms, with a question about gender. And that's to our colleagues in the medical space definition, they call this inappropriate use of language. And specifically, this kind of touches on what Michael said in the panel. There's this sort of essentializing of socially constructed categories such as sex, gender, race, and ethnicity, as if they are some fixed, thing like a radio button that you can simply check, and there's some kind of underlying biological meaning to that, when in fact, these are all socially constructed categories. And that's not to say that race isn't real, that gender isn't real. They're very real, but they're socially constructed. And so when we say misinformation, what we mean is information that may or may not be true, but it's presented in a biased way and in a harmful way. So that's why I kind of make the distinction between like this example of misinformation that is accurate, such as African-American people do in fact are in fact more likely to develop diabetes. And I can't remember if it's type 1 or type 2, so please don't quote me on that. But one of the types of diabetes, they are in fact more likely to develop it. But if you just pose that fact with no context, then that's reinforcing stereotypes about Black people, and also reducing the likelihood for medical professionals to get accurate diagnoses, where in fact, it's not the fact that they're Black that makes it more likely for them to develop diabetes. It's really things like, socioeconomic disparities, the impact of systemic racism, on the stresses that they experience, and things like that. So trying to kind of distinguish between what is, what is true and false, which I think is covered very well by misinformation, versus what is biased and unbiased, which is not. And then of course there's the overlap, right? There's sometimes the biased information is also just patently false. So just to give another example, and we don't have to go on and on, but even the use of the phrase, the Chinese virus, right? That is a highly biased way of describing COVID-19 that obviously led to, an increase of hate crimes against AAPI. So these are the kinds of things that we are referring to when we say disinformation.
Shiri, you have a question in the chat.
Oh, let me reopen the chat window. Thanks. Is it Ushnish? I'm not sure. So there's a power imbalance between CS and other disciplines. How do we address it? Well, that's a very good question. And that's exactly why I'm encouraging technology people to seek out actively collaborators from other fields. I mean, there are some, places where we do see social sciences integrated really well with these systems, like MSR, for example, has amazing social science researchers. Sometimes you see that at Facebook and Google, but by and large, I think many of us are kind of in our little silo, and it's my hope, and what I also do in my life is to actively seek out input from these other domains of research, and whether that's humanities, social sciences, medical field, etc., in order to pull them into this work, because it's easy for us to just develop things based on our limited understanding of these social structures, and it is, we need to understand that not having that information is actively harming the users of our information systems and our recommendation systems. Thanks, Emma, for your comment. Yeah, there's probably a lot there. I'm married to a communication scholar, so that also impacts the way that I view this this work, right? Him criticizing my own and my peers' work in computer science has made a deep impact on the direction that I take my research in. I see a hand from Manel.
Yes. Hi.
Hi, Manel.
Thank you, Shiri. I really enjoyed your presentation with a lot of things. And I wished if I can take a screenshot of your last slide, where you mentioned, so you said we need to, instead of making the AI fair, we need to make, more, I think this one second. Yes, to make the world fairer. Yeah, so you already mentioned the misinformation, a lot of bias information. I would like to know your way, or how you will solve this bias, this misinformation. Do you have any idea? Are you planning?
Thank you. It's a great question, and I don't think that any one researcher can aspire to solve this problem single-handedly. I would be remiss if I thought, I would be a little delusional probably if I thought that I personally could solve it. But I think we can make a dent. I think it's a very big problem, but I think we can absolutely make a dent. And so, we mentioned in the paper that, to the best of our knowledge, there's not been any large-scale analyses of biased information, whether that's online or in other domains. And we're embarking on one ourselves with this project on curricular content. But and also Fabrizio, who's in the audience, and his master's student is right now proposing some novel work on how to study this in social networks. And we're very excited about this collaboration. So I think that there's, an entire wealth of questions that we need to ask and start trying to even answer before we even understand the scope of the problem, let alone how to solve it. But I think that the least we can do is sort of call it out, bring it to people's attention, and start doing our own work so that we can have a sense of, okay, you know, how big is this problem? How do we address it? I think that, you know, I have a colleague in the Allied Health Department at UConn, with which we are hoping to do some intervention work. So how do we change people's minds, right? I mean, one of the biggest impacts right now that we're seeing is that COVID-19 vaccine hesitancy is not evenly distributed across racial and ethnic minorities. And part of that is due to, you know, I could talk about this for hours and I'm taking up the break and so on, but, you know, part of it is due to a very justified mistrust of authorities, that if you look at the history of oppression for Black people in America, for example, it's like, duh, of course you mistrust the government. It's like, no wonder, and science, because all you need to do is look at Tuskegee and like the syphilis studies, and then you're like, yeah, of course, why wouldn't you mistrust the government? But at the same time, you know, we need to be thoughtful about rebuilding that trust and finding ways in which we can, you know, reduce the harm from these problems. So I think my non-answer is that it's a big problem, and that we need to start making inroads into it any way we can. So you know, I encourage you to start studying it as well. And
I would like to put my point here, because I see in this slide a lot of words that tell a lot about me. So you said to make the world fairer, think bigger. So one of the ways I feel I'm now changing my way of thinking of how we do this research. Do we need to assume, and starting from this question, do we need to assume that the data set that we have are the good data set that we need to use?
Yeah, I don't think you can assume that. I mean, that
yes,
you do the best you can with what you have, but one thing you can do is to, for example, query your data set to find out and express the limitations of the data in your paper, because at least that way, okay, you know, this is what I was able to collect, but it's not perfect, but I'm aware that it's, for example, maybe not representative sample of racial and ethnic categories and so on. I'd love to talk offline as more, and maybe we can use the break time, but I want to maybe give,
yes.
Sorry, I didn't catch the session chair's name, but maybe let her officially close the session, and then we can, or sort of post-close, I guess, in this case.
Yeah, there are more questions in the chat, so you can respond to them.
I'll pull it up
in the chat. So yeah, the session was over after your talk, but there are very great discussions after it. So just listening and enjoying.
Sure. Yeah, great. I'm happy to keep answering questions until the next session has to start, which is probably in just a couple of minutes. So Rafael asked, perhaps we can look for data that are less contaminated by biases. Yeah, I absolutely agree. I think it's even that is a non-trivial question. So one thing that, for example, Faricio and I are thinking of right now is, how do you collect data on racial and ethnic minorities in an ethical way without, you know, violating their privacy or their desire to not, you know, to not be outed. For example, if you're thinking about things like, you know, there are various tools out there that do bizarre things like, predict somebody's likelihood to be LGBTQ based on their data. And I'm like, that's super unethical, right? So I wouldn't want to do anything along those lines. We've been thinking about things like using hashtags or self-identifiers when people disclose things about themselves. But even then you have to be careful, because a person might rightly disclose something about them in social media, but not necessarily be thrilled about the idea of being, you know, data being collected on them as a minority. And, you know, as a descendant of Holocaust survivors myself, I don't need to think extremely creatively to think about how these kinds of data collection was used to harm minorities in the not so distant past. So I think that, yes, we absolutely should look for less biased data, but we need to be thinking about how can we do that ethically, and the reality is that the world is kind of biased. So you know, we can try to train our models on non-biased data or on less biased data, but we can't avoid bias altogether. And then Amifa asked, how can we distinguish bits from myths? I think that's a non-trivial question as well, but I think one thing that we're trying to do in the near term is utilize the data that was manually collected from our colleagues in the medical domain in order to build a classifier for misinformation in that particular genre. So I think that will be at least one start. So anyway, I can see that we probably need to start the next session. So thank you everybody for the wonderful questions. And I'm happy to connect offline on Slack or later in the conference.
Thank you. So I think we're at the time announced for starting the last session, aren't we? Sebastian, are you here? Yes, there you are. So our first talk—
I am here. Hello, everyone.
So our first talk of the third session, thank you for sticking with us this morning, is our last long talk of the day. So Sebastian, go ahead.
Thank you very much. And hi, everyone from Copenhagen. I'm very happy to be part of the workshop today. I learned a lot, and this morning's panel discussion was really interesting for me. My background is I'm an associate professor at the University of Copenhagen Center for Information and Innovation Law and at the Norwegian Research Center for Computers and Law. So I'm a legal scholar, and I'm talking about my paper, Recommender Systems in the EU from Responsibility to Regulation. And oops, I hope you see my slides and hear me well. The disclaimer was already there. So I'm a legal researcher, not AI wizard. And also very importantly, in my paper and my talk, I cover developments that are very much in progress in the European Union right now. So if we look at the framework for recommender systems, of course, it's not unregulated what is happening there, right? I mean, you have the platform to business regulation covering the search algorithms of Google. You have cultural policy or the Audiovisual Media Services Directive. You have national regulations like in Germany prescribing for platforms to have certain information for recommender systems. This morning, I heard a lot of talk about the GDPR, but not only the GDPR, already the directive from 1995, which basically contains most of the GDPR, anti-discrimination law, etc. All these play a role. What I am focusing on, what I think is quite interesting, is current developments both in relation to the Artificial Intelligence Act and the Digital Services Act, both of which are proposals for regulations in Europe that have been put forward fairly recently. And if we start with the Digital Services Act, the Digital Services Act is basically looking at its internet law, the question of liability of internet intermediaries, and revising the e-commerce directive from the year 2000, so 21 years ago, that pretty much sets out the basic standards for how intermediaries behave. And that was deemed fit for purpose for a long time, and then not again really. And in December last year, the European Commission proposed its new law. Importantly, I've been involved in the preparatory works. I wrote one of the background studies for the Digital Services Act. I should disclose that. So what the Digital Services Act does is it both looks at the liability of intermediaries, but very importantly, it also stipulates certain due diligence obligations for these intermediaries. And that's where it gets quite interesting. In internet law, most of the focus right now in terms of using algorithms is really on enforcing content. So content moderation, where a lot is about minimizing errors, both false positives and false negatives, where there is the focus of this regulatory intervention. But then recommender systems also become relevant in this context, and this Digital Services Act puts forward the first legal definition in the EU of a recommender system as a fully or partially automated system used by an online platform to suggest specific information, including as a result of search initiated by the recipient or otherwise determining the provenance of information. So that means we're actually not only talking about information filtering, but also information retrieval, this fairly broad definition. What is being put forward is for certain online platforms, and those are very large online platforms. I get back to that in a second in Article 29, paragraph 1, that these platforms shall do two things. Firstly, they need to set out in their terms and conditions in a clear, accessible, and easily comprehensible manner. If you've read the GDPR, this language resembles the GDPR quite a bit. The main parameters used in the recommender system. So that's the first criterion. And the second criterion would be to also list the options that the recipients have to modify those parameters, including an option that is not based on profiling within the meaning of the GDPR. And this, of course, is quite interesting. So on the one hand, this focusing on transparency in terms and conditions, this is not about a specific explanation why are you being recommended this piece of content? This is really just kind of describing the general parameters. And then secondly, also offering an option that is not based on the processing of personal data, pretty much. So this is quite interesting. The European Data Protection Supervisor, fairly quickly after this proposal, came out and said, well, actually, this should maybe not be a opt-out for internet users, but rather an opt-in. So this is being heavily discussed in the European institutions right now. What is also very important with this is only addressing online platforms and a certain kind of online platforms, that's hosting platforms, which basically allow for user uploads. So that would be Facebook and YouTube, but not Spotify, Netflix. And furthermore, these platforms need to be very large, which is covering more than or approximately 45 million users in the European Union. So that would be Facebook and YouTube. I'm not sure whether Twitter has more than 45 million users in EU member states, but potentially this is really only directed at the very large online platforms. So this is the specific rule on recommender systems. But furthermore, and I think this is quite interesting, Article 27 also sets out a new regime where after these platforms would need to put in place certain mitigation measures. And what is meant by that is basically adopting the recommender system in case they identify systemic risks stemming from their service. And this risk assessment would have to be done on a yearly basis by the platform. Now you may ask, what are these systemic risks? And I think the definition is in this draft law right now very, very broad. So this would be dissemination of illegal content, also be any form of negative effect on fundamental rights, for example, freedom of expression, etc. But it would also be the manipulation of that service with an effect on the civic discourse. And this risk mitigation mechanism means that these very large online platforms would be obliged, after having talks with the national member states commission, to mitigate and to change their recommender systems. So this is fairly blurry, really, how this mechanism would work, but I think it's a fairly important proposal to be aware of. Now, I'm switching gear a little. So this is the Digital Services Act, and the Digital Services Act is about online platforms. So we're really looking in this regulatory proposal at regulating internet platforms. A second trajectory is the Artificial Intelligence Act, which some of you might have heard of already, which goes back to this European frenzy of looking at artificial intelligence and culminated in this proposal from April this year. It's really comprehensive. It's very much inspired by European product regulation. So it is quite heavy, but there's nonetheless, I think, some interesting aspects to be aware of when looking at responsible recommendation. The scope of this proposal of the Artificial Intelligence Act is the placing on the market, putting into service and use of a so-called AI system. And this AI system definition that the European Commission is proposing is basically inspired by the OECD's work. So a very, very broad definition that, of course, also covers recommender systems. And then the question is kind of like, what is actually covered? And for that, you need to understand that there is a risk-based approach whereafter there's certain specific uses of AI systems that are prohibited, whereas other very specific high-risk AI use cases would be subject to specific obligations. If we start with the prohibitions, at a starting point, I'm not sure actually what the legislator, this is a screenshot of my document commenting on the proposal. It covers the manipulation by deploying subliminal techniques of an AI system to materially distort a person's behavior in order to cause another person's physical or psychological harm. Now, in a very large reading, and this is currently being discussed in Europe, this might extend to some forms of recommender systems when they're very harmful. There's in a recital, however, an intentional aspect. So I think right now this wouldn't be covered, but this is something that is being discussed. And then the use of such system would be prohibited. The second big aspect of this proposal is high-risk AI systems. And I think I have about 1 minute left. Which would be subject to a variety of design and development principles and rules. The question here, however, is what would be actually deemed a high-risk AI system? And the proposal sets out 8 specific areas. I just have a few examples here. For example, education, vocational training, or in the field of administration of justice and democratic processes. So a recommender systems used in case law retrieval or similar might be falling under this high-risk AI system, with the consequence of having to be compliant with those rules potentially. But really, these high-risk AI systems are fairly narrow and restricted, so a lot of unclarity remains for now. So wrapping up, what am I trying to tell you? I'm trying to tell you that this is actually some really important European developments. They are relevant beyond Europe. 2 different instruments, Artificial Intelligence Act, where the scope is some prohibitions, fairly vague, and very specific areas, with an angle that focuses on the prohibition and on design and development principles. Potentially, this is relevant because there's a lot of emphasis of the voluntary application of these rules to those not covered. Second trajectory, Digital Services Act, covering the recommender systems of very large online platforms, where the focus is very much on end user transparency, but not on an explanation, rather just kind of laying out the basic or the main parameters and some influence over the system by those users. And I think some of the interesting questions here are maybe that can come up in the coming European discussions, whether the transparency of these recommender systems really is so compartmentalized, or whether these are common problems that also maybe need common solutions. So is this really something that should only be discussed in very large online platforms or something else? What I also find interesting is that the influence over recommendations seems to be focusing on the users, but maybe not so much third parties. So who else has influence over those recommendations? And lastly, for this forum, I think my goal is a little to make you aware of these developments because they're relevant not only in the EU, there's this Brussels effect, so this might very well also be relevant beyond the EU. And compliance, of course, is only one starting point for responsible recommender systems. And this is all what I had for now. My paper is in SSRN. If you have comments, there's also a long article forthcoming in Morris Machines later this year. Thanks so much, and I look forward to your questions.
We have one question in the chat.
Yes, let me have a look. Regarding Article 29, you mentioned where large online platforms need to give certain insights in the recommender systems in the terms and conditions. Is this indeed currently done by YouTube and Google? And if so, is it indeed comprehensible in your opinion? That's a very good question, Carlin. So if we look, for example, at Facebook's why am I seeing this system, that would, I think, go beyond what is currently necessary. I have not checked on YouTube's terms and conditions recently, so I'm not sure whether that would be comprehensive enough. The proposal, and this is a proposal currently being negotiated by the Parliament and Council in Europe, is really unclear what the main parameters would be. I think this would be something very use case specific, and depending on YouTube, what are the main parameters there, it might look very different from another platform. So I have to kind of come with a very boring legal answer, I'm not so sure.
Thank you.
Shiri.
Yes, thank you, Sebastian, for the wonderful talk. So at least in my startup, we've been tracking the development of the Digital Services Act with great interest and close attention since its first earliest proposals. So I'm very curious to your opinion about what do you think is going to be the impact with respect to the spread of mis and disinformation? Because I know that is being discussed, but I didn't see you explicitly call that out. So I'm very curious. Do you think that the platforms are going to be held to account for the ability of misinformation to spread on them? And if so, how do you think that's going to be enforced?
Thanks for a really excellent question. So as a starting point, what the EU is trying to regulate is illegal content, and that's much more easy to look at, right? Because that is defined as something that is illegal in one of the 27 member states. Now, mis and disinformation is not necessarily illegal, so it's kind of like what you could call lawful but awful. So something that might be lawful, but you don't want it on the internet. The European legislator has a hard time challenging that. So there is, of course, a code of conduct in these areas, and there is some openings also, I think, in the Digital Services Act. So if you look at the principle behind this risk mitigation, risk assessment, it's going beyond the illegal information. It's actually addressing public discourse. So what I could expect is that the European Commission actually is opening up there for potentially having some kind of mandate to look at what are best practices across online platforms to tackle misinformation in terms of recommender systems, and then prescribe that to some extent to the platforms at large. So I think even though it's not specifically, I don't think misinformation is actually, or disinformation is actually mentioned in the Digital Services Act any place, I still think that it can be quite relevant, and there might be the spec door opening.
Yeah, it was my impression that it was being considered by the Commission, but I may be mistaken. So thank you I stand corrected.
And Shiri, I have to admit, the lawful but awful, I heard that somewhere else, so no credit to me. I unfortunately don't know anymore who said it, but it's a fantastic phrase. Yes. I see also another question in the chat by Ushnish. Is the focus on online platforms due to the headquarters control of these platforms being outside Europe? Simultaneous lack of limitations on European company developed systems. Well, I'm not so sure. I think, of course, there's a geopolitical component to this, and the Digital Service Act would apply to all platforms that operate in Europe and towards European users. So there's this Brussels effect, similar also to the AI Act. I think this is more arising out of looking at 20 years of internet regulation and platform regulation in Europe, where are some issues, and a lot of issues have been identified, mostly in terms of content takedown, but also recommender systems. And I think this is kind of where it's coming from. But I'm not sure that this is a geopolitical primarily question. These rules apply also to European companies. Doesn't matter where they're located.
Okay, thank you. And we can keep the discussion going in the chat or in the Slack. There's a responsible channel on the RecSys Slack where we can keep these discussions going all week. But let's thank Sebastian again. And now we're going to start our short talks to close out the workshop. And our first one is tag boosted explainable matrix factorization methods for multi-style explanation. I believe being presented by Ulfa, who is here. Or is there another author who is here is going to be presented?
It's Timmy. Hi, Michael. It's Timmy, my student Timmy.
Okay.
I know he's online, I think.
I think I see him now.
Yes, I'm here.
Okay, so if you can go ahead and get started. And these talks are going to be quick. We've got 5 minutes for the talk and 2 minutes for questions, and on to the next one. So we'll probably need to have more questions in Slack.
All right, cool. No problem. Thank you. Can you see my screen?
Yep.
All right, so my name is Timmy, Timmy Sutton. I am presenting our paper, Tag Boosted Explainable Matrix Factorization Methods for Multi-Style Explanations. And my co-authors were Pegas Sahib, Mohammed Al-Samari, and Dr. Nasari. We are from the Knowledge Discovery and Web Mining Lab at the University of Louisville. So this is just the basic outline. Since we have such limited time, I'm not going to read through that. So the introduction and motivation for this work. So the black box recommender systems are recommender system models are accurate, but they do not explain their recommendations to users. A very popular implementation or a very, very popular black box model is the recommender systems developed using metrics factorization. And to address this limitation of no explanations, explainable metrics factorization was developed, which is denoted as EMF here. And to add explainability to metrics factorization, an explainability regularization term was added to the MF objective function. And this explainability regularization term pretty much just takes the proximity between users and items in the latent vector space and weighted them by the pre-calculated explainability scores. So EMF models are considered to be accurate and also explainable, but they also have a limitation, which is that they use single explanation style for all users and all recommended items. This becomes a problem because some users prefer different explanation styles, and so this becomes a major limitation for EMF. But Taxplanation was developed by Vig et al. In 2009, and this effectively used tags for explaining movie recommendations. But one limitation of this approach is that it's a post-hoc method, meaning that the explanations had no influence on the recommendation model or the generation of the explanations. And we carried out a preliminary survey that showed that different users tend to prefer different explanation styles for the same recommended items, which means that there's an area there's a need for multiple explanation styles for recommending the same items to users and for explaining the same items to users. So we asked the question, does adding tag-based information affect the performance of explainable metric factorization models while providing multiple ways to explain recommendations? And our goal here is to develop a multi-style EMF inspired models that can explain recommendations using multiple explanation styles without sacrificing the accuracy of the MF models. So our contribution is summarized on this slide, and pretty much what we try to address is this. You have three different dimensions. You have the users, the tags, and the movies. And some users have tagged previous movies using some tags, and some movies have been tagged by other users using some tags as well. Have been described by other users using some tags. So what we try to find is there a path for between a user to an item using a tag? And if such a path exists, then that tag could serve as an explanation for that user for if that movie is recommended to the user. So the relationship between a user and the tag it was quantified by Vig et al. And they called it the user preference, the user tag preference. So that's the relationship between a user and a tag. And the relationship between a tag and an item was also quantified as the tag relevance. And our contribution was we formulated this into three different graphs: the tag preference graph, which pretty much is the relationship between users and tags; the tag relevance graph, which is the relationship between items and tags; and then the user item tag explainability graph, which combines the user and item based graphs. And we came up with two different methods, but because our work is built on the explainable metric factorization method, we have, I'm just going to touch it lightly. So the EMF model pretty much is metrics factorization that has added onto its soft explainability, an explainability regularization term, which is a soft explainability constraint. And this is, this can be calculated by finding the explanation score, which is calculated as the expected rating given a user neighbor the set of neighbors of a user. And so the probability of a user giving a certain rating K to an item given a neighborhood is calculated by finding the neighborhoods of that user who have rated that item in a certain way divided by the neighborhood of the users. So this is an extension of metric factorization, and we add a soft explainability constraints to bring users closer to the explainable items in the latent space. And we extended this work a bit by adding the type boosted multi-style, by adding the type boosting, it's a type boosting term. And what this term does is that it just simply considers users who tag items similarly to the target user. And those users who tag items similarly to the target user have some influence or have greater influence on getting the predicted, on the prediction than users who tag items differently from the target user. I won't go into the update rules, but it's available on the paper. And we find the similarities between users based on their tag preference by taking the cosine similarities between their tag preference vectors. And the main intuition here is to provide explanations for users by using information about users with similar tag preference to the target user. And we also have the relevant tag boosted multi-style EMF method. But this does the same thing, but the only difference is that we use the relevant tag relevance vectors as in order to find the similarities between items. And so the experiment here, I just quickly described what we did in terms of the data sets, the preprocessing, data splits, and all this information is available in our paper. So the results here show, this is the result of the accuracy, and we show that our method performs better than the user-based EMF and item-based EMF in terms of RMSE, but we have to remember that accuracy is not enough. And we also do in terms of relevance, and we see that our method also outperforms the baseline methods in terms of MAPA 10 as well. So just to give an example of what this means is that this is an example of using our method compared to using EMF methods. So if you were to use EMF methods alone, using the neighborhood rating style, you have just this explanations to a user. But using the tag-based method, using the tag boosted, you have this extra information which comes in terms of tags that can help a user understand why Forrest Gump was recommended to them. Using the preferred tags, so the difference between relevant tags and preferred tags are that relevant tags are tags that describe the item, but preferred tags are tags that users use to describe the items, like they sometimes are like sentimental in a way. And in this case, we find that the best type of tags are tags that are both descriptive and also capture some and also capture the user's preference as well. So in a movie like Pulp Fiction, for instance, we can see that this movie we have the influence style explanation. We gave us, this movie was recommended to you because you rated 4 similar movies like this. And also we can see that, this movie has been tagged with crime, comedy, nonlinear, which the user has some preference for by using those tags in the past. But also there are some bad examples where this method fails. For instance, The Mummy Returns. In a situation like Mummy Returns, there was no influence style explanation, and the tag-based explanation was factual. Now, if you've seen The Mummy Returns, you do know that The Mummy Returns is not based on any factual information, so that's a misleading tag there. And for Weddings and a Funeral, we see here that the tags here are just sentimental. They do not give any information about the movie. So we can say that, the tags stupid, horrible, and lying do not give any factual information about the movie, but they've been used to describe the movie by other users similar to the sample user. However, they may provide reasons for users not to watch the movie. So if you find other users like this user and you want to let them know why not to watch the movie, then this might help. But that's not covered in this work. And our conclusions, we developed some type boosted methods evaluation, and the accuracy-based evaluation. In the accuracy-based evaluation, our real tag wins for RMSE, and the perf tag wins for the MAPA 10. So pretty much what we find is that the explainable hybrid methods improve both accuracy and explainability. The explainability aspects was presented more in our paper, but we excluded it, but we showed examples to prove what it does. So these are the references that were used within this presentation. And thank you, and I will answer questions now.
Thank you very much. I'm going to go ahead. We're going to go ahead and get the next presenter's slides up while you take one question.
Okay.
It looks like we have one in the chat. So while you're answering that question, Agaritza, could you put your screen up?
Thank you.
Okay, our second to last talk of the day will be AJ presenting on adaptive boosting for mitigating popularity bias. Go ahead.
Thank you. So first of all, good evening to one and all present over here. My name is Ajay Gangwar and I am here to present my paper on the topic an adaptive boosting technique to mitigate popularity bias in recommender systems. This work is done in collaboration with Dr. Shweta Jain. We both are from Indian Institute of Technology, Ropar. And recommender systems suffer from different types of biases issues like gender bias, racial bias, and many more. But our paper focuses on the most important fairness issue, which is popularity bias. The basic idea of popularity bias is that users are more likely to provide feedback on the popular items or the mainstream items than on the non-popular items. As a result, the observed user feedback, which we see, is biased towards the popular items compared to the true interest of the user. Due to this, few products dominate the market and thus offer very few opportunities for creativity and innovation. And to verify the presence of popularity bias, we plotted a graph between the movie on the x-axis and the number of users who rated that movie on the y-axis for the Netflix dataset. And the dataset contains around 440K users and around 2,000 movies, and around total number of ratings presented around 10 million ratings. Now from the plot, we can clearly see that the few number of movies received very high number of ratings, while the most of the movies received very few ratings. Hence, it shows the presence of the popularity bias in the data. Now, exploring and mitigating popularity bias is not a new problem and have been explored in many works. To overcome this issue, several algorithms have been proposed, which mainly focuses on improving the accuracy of the recommender system. And some other algorithms have also been proposed, which focuses on improving the popularity bias through diversification. Accuracy as a measure is biased towards popular items. That is, it promotes better accuracy for popular items compared to the non-popular items. And naive exploration of non-popular items may lead to the lower accuracy of the system. So we need a measure that promotes non-popular items while maintaining the accuracy within the acceptable limits. And we proposed a new metric for measuring the popularity bias. What this metric does is it first divides the items into two sets, namely popular sets and non-popular sets, based on the threshold tau. It is a hyperparameter which is given as input to the algorithm. And finally, the set of all those items that obtain the number of ratings more than the number of ratings, threshold number of ratings, will be regarded as popular. And whereas the set of items that receive the less number of ratings than the threshold number of ratings will be considered as non-popular. And after that, we have taken the mean error, which is computed for both popular and non-popular sets separately. And finally, the difference between them is taken, and which is used to determine the popularity bias. Now, the main goal is to minimize the popularity bias while maintaining or maximizing the accuracy. Now, to reduce the popularity bias, we propose a novel algorithm named FAirBoost, which is inspired from the Adaboost algorithm used in the classification setting. And the results showed that our algorithm significantly reduced the popularity bias present in the data while maintaining the accuracy within the acceptable limits. Now, the intuition of our algorithm goes like this. So first, the input data is taken and it's given as input to any traditional algorithm. We have taken collaborative filtering here. This algorithm gives us a learned model A1 hat as output. Then the weight updation is done on the data. And the intuition of it we will see afterwards. This weighted data is given as input to the algorithm and gives A2 hat as the output. And this keeps on going till the number of iterations reach. And at last we get the final model BX, which is the weighted combination of all these learned models in the middle. And the intention of the weight updation was like this: like our goal is to reduce property bias as well as increase the accuracy. So in every subsequent step, iteration weights are updated by multiplying them with the exponential error term and the cost function term. Now, the exponential error helps us to increase the accuracy, while the cost function helps us to reduce the property bias. Now, this exponential term is calculated same as this is calculated in the Advertise algorithm. And the cost function intuition is like this: like for popular items, if the error is high and popularity bias is highly positive, then we have to somehow increase the weights of these items. And as these items were discriminated in the last iteration. Similarly, for the non-popular ones, if the error is high and the probability bias is highly negative, this implies that the weight of the non-popular items need to be increased, as these are the ones which were discriminated in the last iteration. So, and the calculation of this cost function is demonstrated here, which is given, which we can be seen from the following equation. And now we have applied our algorithm on various datasets like Netflix dataset, Movielians dataset, Amazon dataset, and the Yahoo dataset, and we have compared the results with the most popular ones. From this table, we can see that our algorithm has performed significantly better than all of the algorithms on the Netflix and Movielians dataset. And this table shows that our algorithm also performs well on the Amazon and Yahoo dataset. Now, in this paper's final conclusion was like in this paper, we have provided a metric that continually measures the popularity bias present in the data. And we have proposed a fair-boost algorithm to mitigate the popularity bias. And we have also evaluated the performance of our algorithm on various datasets. And the result shows that our algorithm outperforms existing algorithms on the popularity bias metric. Thank you.
Thank you. We have time for 1 or 2 questions. I don't see any in the chat yet, but if you want to ask a question, either drop it in the chat. Okay.
Yes, definitely, Shall I will make the code online.
And Gustav, why don't you go ahead and start your screen sharing so we're ready to go when we're done with questions. So do you see the question, Ajay?
Yeah.
Okay.
Like first one is like